Welcome to Honey of Knowledge. This is Ashish Gourav, and today we will be adding on game theory to the MSQE coursework series we are doing. The game theory coverage of this series would be undergrad level, but it would also be covering few master's level concepts so that the series gives a justice to the MSQE coursework series. Let's start with game theory. A game in strategic form or normal form, as is the terminology in game theory, is represented by a tuple. And in this tuple, let's look at each term individually. So N denotes the set of players. This is a finite set. It could be 2, 3, 4, 5 and so on. SI is the set of strategies for player I. So S1 is a set of strategies for player 1, S2 is the set of strategies for player 2 and so on. UI is the utility of player I for player 1, 2 and so on. UI for 1, U2 for 2 and so on. We will go to utility, but first let's look at the strategy part. Strategy is kind of a contingency plan. It's a plan of action for all situations. To understand strategy, just think of any kind of a strategic interaction. You are talking to your friend and both of you are getting bored. Any of you could leave the discussion. But the thing is, you have two strategies. Either continue the discussion or leave the discussion. And both the players, you and your friend, have these two strategies. Either continue with the discussion or leave the discussion. So this is a simple example of a strategy. So if you take a different example, let's say you have a penalty shootout and the person who is kicking the ball has three strategies. Either he can kick to the left, kick to the right or kick to the center. And similarly, the goalie or the goalkeeper has three strategies. He can stay put at center or move to his left or move to his right. So any kind of a strategic interaction, when you have more than one player, two or more, then you automatically induce a set of strategies for each player. So this is what strategy is all about. Now, what is utility? Let us say you and your friend are discussing something. You decide to leave the table and your friend stays there. So obviously it's not good for the friend and it's somewhat not good for you, but still you are better off by leaving that table. But the idea is how to quantify it. I mean, it could be that your friend leaves the table, or it could be that you leave the table, or both of you simultaneously decide that you want to leave the table, or both of you stay at the table. Similarly, in the penalty shootout situation, you can have the goalie, the goalkeeper jumping to his left, the shooter kicking to the right. Now, obviously, there would be combinations in the interactions when then there would be a goal and there would be a combinations in which there won't be a goal. So you need to assign payoffs to all such combination of strategies for all the players. So essentially, utility is for each player for each set of strategy combinations for all players, and those strategy combinations are known as strategy profile. So if you take out the strategies of all players and make a set out of it for every situation, so you will have strategy profiles. Now if you have strategy profiles, for all strategy profiles you can associate a utility with it for all the players. So on your screen you can look at the mathematical form for utility. So you can pause the video and have a look at this definition of utility. It's pretty straightforward and nothing to be worried about. It's just that you are combining the strategy of each player, forming a strategy profile and associating a utility for all players with that strategy profile. Let's look at an example. You must have heard of prisoner's dilemma. I mean, it's a situation when you have two prisoners who are being interrogated by the police officers, and if they both confess, obviously they will be given a kind of sentence. If one of them confesses and the other remains quiet, obviously the prisoner who is remaining quiet will be given a harsher punishment. Let us suppose if both the prisoners do not confess. In this situation, both the prisoners would be given no punishment. It's best for the prisoners to not confess. simultaneously. One of them confessing and the other remaining quiet is not good. And both of them confessing is kind of okay but not great. Let's look at the game structure of this. N here is 1, 2 because you have two players. Strategy for player 1 is either confess or do not confess, and same for player 2. Strategy for player 2 is also confess and do not confess. Now once we have this basic structure, we can associate all strategy profiles with a utility. So what are the strategy profiles here? Confess, do not confess, 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 not confess, confess, do not confess, do not confess. So 2 cross 2, we have 4 strategy profiles here. So let's assign utilities to these strategy profiles. This is utility of first player when he chooses to confess and second player is remaining quiet or he's choosing to not confess. So obviously player 2 will suffer a greater damage because he is remaining quiet and police officers have extracted confession. So utility of player 1 would be very high. And as here we are talking about punishments, high for us means 0. He is not getting punished at all. But as player 2 was quiet, he did not confess, he will get the harshest punishment, which is, let's say, 100 years of imprisonment or lifetime imprisonment. I'm taking 100 years as lifetime imprisonment. If you flip the situation, player 1 not confessing, player 2 confessing, you will have a similar outcome, but result will be flipped up. The utilities will be flipped. So we'll not go to the flip case because that's just repetitive. What about if both of them choose to confess? Utility of 1 if 1 is confessing and 2 is also confessing. Utility for 2 if both of them are confessing. So over here, if both of them are confessing, they will be given a milder punishment, but both will be given some sort of punishment. Let's say 10 years of imprisonment. So you'll have a -10 and -10. So now we have looked at both of them confessing. What about both of them denying the crime or not confessing, remaining quiet? Obviously, they will be given a kind of a minor punishment, like 1 year of imprisonment. So it will be -1 for both of them because the profile is very symmetric. Not confess, not confess. So here we can construct a payoff matrix given this structure of utilities. And I think you would be very familiar with payoff matrices. So let's construct a payoff matrix out of this. Remember these numbers, so we'll be using these numbers to make the payoff matrix. I'm pretty sure that this kind of a payoff matrix is quite intuitive for you to get the utilities for all set of strategy profiles. Confess, 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 not confess, not confess, confess, not confess, not confess. So you can have a look at your payoff for all the strategy profiles and look at this payoff matrix to compare them. Now if we have this payoff matrix, we generally go to the next exercise of calculating the Nash equilibrium. What will be the outcome of such an interaction? We will not be finding the Nash equilibrium in this lecture. It will be covered in the next lecture. With this, we will conclude the first lecture on game theory as a part of MSQE curriculum at Indian Statistical Institute. I hope you found it useful. And if you found it useful, you know what to do. Like this video and subscribe to my channel. Also press the bell icon. And I will be coming up with next lecture of game theory soon and the other parts of econometrics and the usual stuff which is coming on channel. So till then, bye bye.